Well, we're studying chemical bonds, so maybe a good place to start is by asking, what is a chemical bond? What is this blue line that we see right here? And let's see how we can subdivide it into various types. Remember, as always, these are sort of man-made decisions as to what types there are. In reality, it's more likely to be a continuum. This is Screencast 7.2. Well, there's our little bond, and what is it? A nice way to define a chemical bond is the force that holds two atoms together. There is some kind of driving mechanism that forces these things to be so intimately associated with each other that the properties of the substance are determined wholly by the molecule, not by the individual elements. Hydrogen's a low boiling gas, the lowest. Oxygen's a gas. You stick them together, you get H2O, and it boils at 100 degrees Celsius. So these bonds are really important. But some don't form chemical bonds at all. You might recall that the noble gases are all good to go. That's a key feature in understanding why the other ones all tend to. And by the way, they can get the noble gases to form a few bonds when they really push hard. But why do elements form bonds? They don't really ask why. They don't have these little eyeballs or brains. But when they do form these bonds, they gain stability. And so there's a driving sort of thermodynamic force, if you will, if you want to put it in a complex way. They obtain noble gas configurations. When they become like noble gases, they gain dramatic amounts of stability. Fluorine gains 1 electron, sodium loses 1 electron, that sort of thing. And we humans have decided that there's a few basic types. If the bond is between two metals, and that means this purple region here, left of the staircase, we call that a metallic bond. An example would be an iron-to-iron bond. It's not really a simple bond, is it? It's usually this big lattice, this huge lattice work that forms. If you got a metal and a nonmetal, and by the way, they always begin the naming with the metal, then the nonmetal. They don't say chloride sodium, they say sodium chloride. We call that an ionic compound. I'll oftentimes use the word salt, since it seems just, even simpler. And an example of that would be sodium chloride. If everything is in the nonmetal region, no metals at all, that is the world of organic chemistry, and boy is it fascinating. I suppose technically it should have carbon in it to be organic chemistry, but it's the elements of life, and this is the covalent world. Examples could be a carbon-chlorine bond. So those are the three types. Don't forget, in reality, it's a sort of continuum in terms of the properties between metal-like, metalloid-like, salt-like, covalent, sharing electrons, transferring electrons. It all sort of blends from one edge to the other. This is Screencast 7.2.